Hi everyone, this is Brett Sanders, and we're working through a set of PRIMo tutorial videos to help people set up models and run models and make sense of model results. This is the sixth instructional video, and in this one I'm going to explain how to configure this so-called drain file, which can be used to route runoff into street curb inlets and move the water from the curb inlet into a nearby drainage channel so that the model can continue to route that flow as an overland flow. So why don't we go ahead and open that file up, and you can see the table of input data that's required to use this feature. This sample file has been set up with first input is a label. It's called the number of drains, and in this case it's 3. And then there's a table that's got 3 rows in it describing the properties of 3 different curb inlet type drains that flow to a nearby drainage channel. So what's needed to fill out this table, aside from an ID like 1, 2, 3, is the X location, X coordinate of the inlet, the Y coordinate, the length of the drain along the edge of the street, the height of the drain, that's typically like the height of a curb, and then you've got a discharge coefficient for the drain, and then the outlet location for the drain. So this sample file has been set up with sample data. I don't know that there's drains at these specific locations in this study area, in this Miami-Gate study area, but it's meant just to illustrate how to set up this file. So I've got 3 different coordinates where I've imagined there are street inlets. You can see that they all have the same latitude, but slightly different longitudes, and I route them all to the same location with a latitude and longitude. And we can get a sense of where those are by running the PRIMo prep script. It'll generate a graphic of the study area. And so if we take like a location like -80.26, that puts us right here. Okay, and then the 25.8 takes us up to here. Okay, so we're doing 25.8 with 80.260, 80.262, and 80.264. So basically we've got imagining a curb inlet here, another one here, another one here. So there's like 3 drainage inlets envisioned up in here, and they're all routing to a location. Let's get these graphics out of the way and pull back number 3. So they're all routing to a location which is -80.26, 25.794. So 25.794 is getting pretty close to 29.6. So 25.794 puts us sort of inside this channel, and the -80.26 puts us here. So the outlets are here. The inlets, as I mentioned before, are up here. The outlets are here, and that's based on these point locations. Now the dimensions of the drain are, you'd have to visit a site and see what size drains are typically used. We've put in some sample numbers here, imagining a curb inlet that's 2 meters long, 0.2 meters tall, and the discharge coefficient of 0.5. So that is the essence of how that file is set up. To then use this input file, what you need to do is just turn this fellow on and let the model run. And I'm going to run a scenario where I have a rainfall of 100 millimeters over 60 minutes, so 10 centimeters an hour. I've got no point sources, no other forcing. All my boundary conditions are set to 1, and the boundary options are set to 0. So all the boundaries here are just treated as walls. We just got rainfall hitting the ground surface. It's initially dry, and some of the water is going to be routed through these drains and then sent into that canal to collect the water. So make sure I save these files, save that guy, and we'll run the script, run Primo, and I'll take just a few seconds to run. Wait a moment. So we're expecting then some additional accumulation of water down here based on water that was routed through into a storm inlet and then out to here. I know what's coming here, and to give you a heads up, it's hard to even tell the difference between the rainfall that's accumulating in the canal and the water that's routed from this area into the canal. So it's hard to see a real strong influence of that drain in this particular sample test case. But you could always configure a different test case to create something more striking. But here's the rainfall, and now we're going to have just additional accumulation of water down in here it sort of shows up in here because some of the runoff from this area is getting routed into that canal. So that's the gist of how the storm drain routing works in Primo.